All right, different method for doing these videos. So let's see how this works. I've done a couple for pre-calc honors already, so I think this is going to be our new system. So go ahead and copy down what you see. Okay, so 6.1. Square roots and exponents undo each other. So 5 squared equals 25 is equivalent to saying the square root of 25 equals 5. So for example, if we want to solve the equation x squared equals 25, we use square roots. If we want to solve the equation x cubed equals 8, we use cube roots, and so on and so forth. So let's show you what I mean. If I want to get rid of an exponent of 2 in the equation x squared equals 25, I'm going to take the square root of both sides, and the exponent and the square root cancel each other out, and I end up with x equals, so the square root of 25 is 5, okay? Now, so we need plus or minus there, and you can see directly below this that I'm going to explain the plus or minus in a minute. So I'm going to hold off on that explanation. If I want to get rid of a cube now, x cubed equals 8, I'm going to use a cube root so that that cube root cancels out with that exponent of 3. And now I need to think what times itself equals 8. That's what a cube root means. So x equals 2. This is an odd root, so I don't need the plus or minus. So let's talk about that for a second. Why do I need the plus or minus when there is an even root? So keyword here is the even root. So think about it this way. What values can I plug in for x in this equation that make that a true statement? Well, 5 squared is certainly 25, but also negative 5 squared is 25. So I need positive 5 and negative 5 in order to get the solutions, all solutions. Remember, this is like I'm your boss and I'm paying you with a grade, and I'm not going to pay you unless you give me the full answer, okay? All right, so go ahead and copy down what you see. Okay, so we just talked about a cube root, fourth roots, fifth roots, etc. The root index right there tells us how many times we're looking to multiply, and then the radicand is the number underneath. So let's evaluate the cube root of negative 27. Okay, so this is asking what times itself equals negative 27. Got to get used to this delay. That almost looks like a frowny face with like arms sticking out, doesn't it? What times itself equals negative 27. So the first thing we need to be comfortable with is we can have negatives under odd radicals, because a negative, well, that's not what I meant to do. A negative times a negative times a negative is a negative, right? So if there's an odd number of things that are being multiplied together, the answer is negative. We'll talk about even in a second. And then I need to I just need to practice these and get good with numbers to think about what times itself equals 27. So negative 3 times negative 3 times negative 3 equals negative 27. So the cube root of negative 27 is negative 3. So let's talk about negatives under even radicals now. So I'm looking for what times itself is equal to negative 81. Well, what's a negative times a negative times a negative times a negative? Well, a negative times a negative makes a positive, right? And then another negative times a negative makes a positive. So there's no way to get a negative when I multiply something by itself 4 times or 2 times or 6 times or any even number of times. So there is no real root here. So when we have a negative under an even radical, the answer is no real root. Now, we just have to be a little bit careful because sometimes we need to think PEMDAS. PEMDAS is always the rule for math. No matter what math you're doing, we always need to think about PEMDAS. So I need to do the parentheses first here and turn this into, instead of -7 squared, I'm going to do -7 times -7 is 49, and then the square root of 49 is 7. But over here, this is asking me what times itself equals -49. Well, there's no number times itself that equals -49. I could do +7 times +7. Nope, that doesn't work. I could do -7 times -7. Nope, that doesn't work. There's no number times itself that equals -49. So similar to B, we're going to write no real root. All right, so take a minute to copy. Let me scroll a little for you. Go ahead and copy that. All right, so when variables are involved, so we're going to be taking roots of expressions involving variables, we must use absolute value to ensure that our answer is positive, since we don't know whether a variable represents a positive or a negative number. Now, if the root is odd, the answer doesn't have to be positive, like we just talked about. So maybe write yourself a note. That's all going to show up at once. That's a little bit of a delay. Wow, that's a bad delay. So I'm going to move on and watch for that to pop up. There we go. Of course, as soon as I say I'm going to move on. So maybe write yourself a note there and say like see above or something like that if you're afraid you're going to forget why the answer doesn't have to be positive. It's the even roots, and we talked about that directly above. So let's evaluate why. So according to this rule that we have right here, if I'm gonna take the a root, I should say, here, let me use, okay, if I'm going to take a root, then this is going to cancel out, and we're going to end up with a, just the radicand, if n is odd, okay? And then they're still going to cancel out, but we're going to end up with the absolute value of a if n is even. So first thing I need to figure out is there is no root index in this first problem underneath. Why? Well, we know it's a 2. So we know that it's even. So that means I need to come out, according to the rule, I'm going to come out with absolute value of -7. And we know the absolute value of -7 is 7. Now I want to verify the rule for you for a couple different cases, okay? So let's do this problem using PEMDAS. Well, we already did it. We did the exponent first, so we're going to have the square root of 49. And then we know the square root of 49 is 7. We get the same answer. Either way. So I'm just showing you why that rule works, okay? So by this rule, I'm going to cancel those out, and then I'm going to end up with the absolute value of -2 because this is even root, an even root index. And that's going to equal 2. We know the absolute value of -2 is equal to 2. Now, if we do this the long way using PEMDAS, we're going to do the exponent or the parentheses, however you want to think of it. -2 times -2 is 4, times -2 is -8, times -2 is 16. So this is the 4th root of 16. And then we want to think about what times itself times itself times itself equals 16. Well, we just kind of talked through that. It's 2. Again, same answer. Right? And then the last one. Now this one is odd. The odd says that if the the numbers are the same, the root index and the exponent, then these are just going to cancel out, and I'm going to end up with the same number as what's under the radical. So I'm looking at the top. I'm looking at this top case here because n is odd. Okay, well, let's do this the long way. The cube root, so -2 times -2 times -2, that's -8. And then the cube root of -8, we talked about something similar to this. What times itself is equal to -8? That's what this question is asking. Well, yeah, of course it's -2. And again, same answer. All right. So let's put this in action and then we'll be done. All right, so first thing I want you to think about is this is an even root. There's no root index there, but whenever there's no root index, we know it's a square root, so it's even. That means we're going to need absolute value. I'm going to go back to some pretty basic Algebra 1, and I'm going to remind myself that this is the same as that. I can break up radicals when there's multiplication or division underneath. And then we all know the square root of 81, but we might need to think about this for a second. What times itself equals x to the 4th? So x squared times x squared. This is why we reviewed those properties of exponents. So we're going to have 9 times the absolute value of x squared. Oops. Let me try that again. The absolute value goes around the whole thing. You could put the absolute value around the 9, but we already know the 9 is positive. Okay? The 9 is already positive, so I don't need an absolute value around it. Oh, but on that same note, now let's stop and think for a second. What do we know about x squared? Any number raised to an even power. Well, that's already positive. Since it's already positive, we actually don't need the absolute value. So there's going to be some times when you have an even root index where you need the absolute value, and there's going to be some times where you don't need the absolute value. It's going to depend on this. So let's just write a note here. When the exponent is even, we don't need the absolute value because it's already positive. We don't need to force it to be positive. Okay? All right, so let's do this again. So we're going to do the 4th root of x to the 12th and the 4th root of y to the 16th. So this is an even root index, so we need the absolute value, at least temporarily, and then we'll check it at the end again. And then this is asking, so again, this is why we reviewed those properties of exponents. I'm going to do it with one of them, but not with both of them. And it looks like I have more space for the y, so I'm going to do it with the y. I want to know what times itself times itself times itself is going to equal y to the 16th. So we know it's got to be y. The question is just, what is the power? So remember, when we have these powers being multiplied together, you guys did this on the con, we add those exponents. So I want to know something plus something plus something plus something equals 16. Well, those powers each need to be 4. 4 plus 4 plus 4 plus 4. So this is going to be y to the 4th. And then think of it the same way. Something plus something plus something equals 12. Well, that's a 3. Okay. We said we needed the absolute value because it started out as an even root index. But y to the 4th is always positive. No matter what the value of y is, if I plug it into the y to the 4th, it's going to end up being positive. So I can actually drop the absolute value around the y and just keep it around the x because the x is odd. So even means we don't need the absolute value. Odd means we need to keep it